class, this is Mrs. Leach. This lesson is on polygon angles. Our learning targets for today's lesson are I can subdivide polygons. I hope that you hear the word divide in subdivide, and that will help you when we come to that part later in the video. I can find patterns in the sums of angles of polygons. Remember, sum means to add, so we're going to be adding up angles in polygons. All right, so we learned in previous lessons that the sum of the angles in a triangle always equals 180 degrees. So any type of triangle, if you added up the sum of all of the angles in a triangle, it would always equal 180. But what if I want to find out the sum of the angles in a quadrilateral? Remember, quadrilateral has 4 sides. All right? So we're going to learn how to do that. So angles and quadrilaterals. The sum of the angles in a quadrilateral is always 360 degrees. Why? Well, I'm going to show you. If I subdivide my, it's a little bit off, my quadrilateral into 2 triangles, I have a triangle here and a triangle here. And since I know that the sum of the angles in a triangle is always 180 degrees, well, now I have 2 triangles. So I have 180 degrees plus 180 degrees. And we know that that equals 360 degrees. So I can subdivide any quadrilateral to equal 360 degrees. We have 180 in this triangle, 180 in this triangle, which means it would be 360. I could divide this quadrilateral into 2 triangles. I could divide this into 2 triangles. And there are multiple ways to do that with our different triangles, or different quadrilaterals. So here are some rules about triangulating polygons. Triangulating just means making triangles, dividing your polygon into triangles. Just kind of a fancy word for that. So here's the rules. To triangulate a polygon, the polygon must be left with only triangles inside of it. You can't have any other shapes inside the polygon except for triangles. You cannot overlap your triangles. They can't cross over each other. And, like I said before, there are multiple ways to triangulate some polygons. So I'm going to show you an example of this. We have 2 hexagons here, and I'm going to show you 2 different ways to triangulate these. So I could do and unfortunately I'm on the smart board, so it looks a little bit goofy. It should be really lined up with each vertex, each corner, but you know how the smart board is, sometimes it doesn't land right where I want it. So we would have 4 triangles in this hexagon. So that's one way to do it. And notice that I only have triangles left. There's a triangle here, a triangle here, a triangle here, and a triangle here. So there's only triangles left inside of it. My triangles are not overlapping. And I'm going to show you another way to triangulate this same shape, this hexagon. So here's the other way. I can go like this. So now I have 2 triangles, but I'm left with a rectangle in the middle, and I can't have that. I can only have triangles. So I can divide that quadrilateral, that rectangle, into 2 triangles also. So now I have, here's a triangle, here's a triangle, here's a triangle, and here's a triangle. So I've got only triangles again, My triangles do not overlap, and I've shown you multiple ways to triangulate this shape, this hexagon. And that's it.